Good morning, class. We are looking at Chapter 7, Systems of Equations and Inequalities. 7.2, Systems of Equations, 3 variables. So we covered systems of linear equations in 2 variables, and now the same thing in 3 variables. The objectives are to solve systems of equations and application problems. For systems of linear equations, which is a group of 2 or more equations. That is the definition. System of equations, a group of 2 or more equations. Types of systems. A system of 2 linear equations in 2 variables can have one solution, no solution, or an infinite number of solutions. Inconsistent system. The system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts. And here's an example as far as the graph is concerned and as far as the equations are concerned. So M1 equals M2, in this case equals 3. B1 is not equal to B2. That means their y-intercepts are different. In this case is 1, in this case is -2. If you go by substitution or addition method, you end up with a contradiction such as 0 equals 7 indicates the system has no solution. The system is inconsistent. Consistent system with independent equations. The system has a single solution at the point of intersection. The graphs are different. They have different slopes. So for example, if you look at this case, you have 2 equations. You graph the lines, they intersect. The point of intersection is the answer. And all you have to know is that their slopes are different. Consistent system with dependent equations. The system here has an infinite number of solutions. The graphs are identical. They have the same slope and same y-intercept. So you see 2 different equations, but if you solve for y, they become identical. They have equal slopes and equal y-intercepts. If you were to solve it by a method of substitution or addition, an identity such as 0 equals 0 indicates the system has an infinite number of solutions. The equations are dependent. Solving graphically. To obtain a solution to a system of equation graphically, graph each equation and determine the point or points of intersection. Solve by substitution. Step 1, isolate the variable in one equation and solve for that. Step 2, substitute for that variable in the second equation. And in short, when you want to solve for that specific variable, choose the one that has a coefficient of 1 or -1 so it doesn't create any fractions. Makes it easier that way. Solve by addition, also known as elimination method. If necessary, rewrite each equation in standard form, meaning ax plus by equals c. If necessary, multiply one or both equations by a constant so that when the equations are added, the sum will contain only one variable. Add the respective sides of equations. This will result in a single equation containing only one variable. Solve the equation obtained in step 3. Substitute the value found in step 4 into either of the original equations. Solve the equation to find the value of the remaining variable. Write the solution as an ordered pair. Check your solution. This is the process, but of course, it's easier said than done. We've gone through the process. Practice can help understand it better. Now, section 7.2, systems of linear equations in 3 variables. Types of systems. A system of 2 linear equations in 2 variables can have one solution, no solution, or an infinite number of solutions. The same thing goes with 3 variables. The equation 2x minus 3y plus 4z equals 8 is an example of a linear equation in 3 variables. The solution to this type of equation is an ordered triple of the form x, y, z. Remember, in the case of linear equations in two variables, in the case of two variables, we have x and y. Here we have x, y, z, although we can use other variables. So one possible solution to this equation, 5x minus 3y plus 4z equals 9 is 1, 2, 3. If you replace the x with 1, you get 5. Y with 2, you get minus 6. And let's do this actually. When we plug in, we get 5 times 1 minus 3 times 2 plus 4 times 3. And they do add up to 9. That's one possible solution, everybody. All right, let's move on. Types of solution sets. A consistent system of equations with a unique solution. A single solution if the planes intersect at a single point. That ordered triple is the solution to the system. Point of intersection as an example. An equation in 3 variables represents a plane. A dependent system of equations. Infinite number of solutions. If the 3 planes intersect along a line, the system has an infinite number of solutions, which are the coordinates of any point along that line. So if you have a bunch of it, and they have a line in common, every point of the line is the solution. If all 3 graphs are the same plane, the system has an infinite number of solutions, which are the coordinates of any point in the plane. So all 3 are the same. Example, you obtain a statement that is always true, such as 0 equal to 0. If we go through the process of solving by substitution or elimination, we end up with a true statement and identity. An inconsistent system of equations with no solution. If all of the planes are parallel, the system has no solution. Pairs of planes also can intersect as shown. However, because all 3 planes do not have a common intersection, the system has no solution. Example, you obtain a statement that is always false, such as 3 equals 0. So either they're all parallel, or they may intersect, but the way they intersect is not in common among all 3. Determine whether this triple 2, comma, negative 1, comma 3 is a solution of this system. So you have to check with each and every one of them. In all 3 equations, replace the x with 2, y with negative 1, z with 3. Let's start from the beginning. The first one, let's replace them accordingly. 2 and 3, 5 minus 1 is 4. So this is a true statement. So far, it's fine. Let's look at the second equation. 2 times 2 minus 2 times negative 1 minus 3 This is a 4 plus 2 minus 3, and 3 equals 3. That's a true statement also. Let's look at the third equation. Minus 4 times 2 plus negative 1 plus 2 times 3. Minus 8 minus 1 is negative 9, plus 6 makes it negative 3, which makes it a true statement. And because the triple 2, comma, negative 1, comma, 3 satisfies all three equations in the system, it is a solution for the system. Systems in 3 or more linear equations are solved the same way systems of 2 linear equations are solved, by using either the substitution or addition, also known as elimination method. So we want to solve this. And it's easy to see that substitution will do the job because x is given. So into equation 2, if I put the x equals negative 3, I can find y. So 3 times x, 3 times negative 3 is negative 9, plus 4y equals 7. You move the negative 9, add it to 7, divide by 4, y becomes 4. So we have x and y. All we have to do, go to the third equation, plug in x and y. So we get 6 minus 12, or negative 6. We move it to the other side, becomes positive 6 and 19, 25. Divide by 5. And you have the solution set. The order triple, negative 3, positive 4, positive 5. Normally we check the solution. At this point, the reason you don't have to check, because this was given. From here you got the y, and from here you got the z. So in essence, you have already checked. We want to solve this system. And I'm using numbers 1, 2, 3 to refer to them as equation 1, equation 2, equation 3. It makes it easy to go that route. Now, first we have to decide to get rid of some variable. And you always go with the easiest that has the least number of steps. Notice the third one and the second one, they have plus z and minus z. You don't really have to do anything, just combine these two, and therefore you can eliminate z. So we're going to combine the second one with the third one. When we add them up, these two cancel each other. And These two give us 3x. Let's do this. If we add them up, these two cancel each other. So we add both sides. Left side, 2x and x is 3x. Y and y is 2y. This go away. These two cancel each other, go away. The right side equals 2 and 2, 4. Now, I put number 4 next to it, meaning this is equation number 4, because we're going to need that. So, which variable did we eliminate? Z. From which equations? 2 and 3. Which equation has not been used yet? Equation 1. So equation 1 must be used with one of these two. Which one makes no difference, but you have to get rid of the same variables. And that's the idea. So we're going to eliminate z from equation that hasn't been used 1. And one of these two equations, we can go with 2 perhaps, because we see minus here. So it makes it easier. As we multiply this one by what number? Since I want to get rid of the z, I don't have to do anything here. I'm going to multiply this one by 6. The result is minus 6z here. They can cancel each other. So let's multiply both sides of this equation by 6. So this doesn't change. This becomes 12x plus 6y minus 6z equals 12. We add them up. These two cancel each other. So we get 3 and 12, 15x, 9 and 6, 15y, 3 and 12, 15. And we give it the name 5. If you look at equation number 4, it has 2 variables. If you look at equation number 5, they have 2 variables. You can put them next to each other now, 4 and 5. Okay. So we are back in the previous section. We are dealing with systems of equations that has 2 variables. So if we decide to get rid of one of the variables, for example, if I want to get rid of x, I can multiply this one by -5 to get rid of it. If I want to get rid of the y, I got to multiply this by, for example, by -15, this one by 2. So it's better and easier. You want the least number of steps. So let's multiply this one by -5. So we're going to eliminate x from equations 4 and 5. Multiplication by -5 gives us -15x minus 10y equals minus 24. Equation number 4 changes to that. Now we are going to combine the left side, combine the right side. As we do so, these two cancel each other. These two add up to 5y. These two add up to -5. Division by 5 gives us -1. So we have y equals -1. Now, remember equations 4 and 5, they have only 2 variables. So you have to go with either 4 or 5 to find the other one. Y is given, so the other one for 4 and 5 would be x. So for example, if you use equation number 4, which is 3x plus 2y equals 4. You say 3 times x plus 2 times negative 1 equals 4. You have negative 2. You take it to the other side, becomes positive 2. Three x becomes 6, x becomes 2. Now, you go to the original equations. There are 3 of them, and probably this is the easiest one to use, equation 3, and you plug in x equals 2, y equals negative 1 to find z. This is 1. Subtracted, you get 1. And the solution becomes x, which is 2, y, which is negative 1, z, which is 1. Now, it is extremely important to know we are not done. We have to check. We must check. So how do you check? You check with the first and second equation. So just as an example, if I put 3 here, I get 6. I put negative 1, I get minus 9, and 6 is negative 3. 6 times 1 is 6. They add up to 3. You can check the second one. So you should check everything to be on the safe side. And it doesn't take long for you to check it. So make sure you check. Geometric interpretation. The following is a geometric interpretation of the solution 4, 5, 3. So we have x, y, z. So we go 4 in the positive side. This is the positive side of x. Inside would be the negative. Here's the positive side of y. Here's the positive side of z. So we go 4 along the x-axis, 5 along the y-axis, and 3 up along the z-axis. It's a 3-dimensional space, x, y, z. We want to solve this equation. This system of equations, x plus y plus z is 6, x plus 2y minus z is 2, x minus y plus 3z equals 8. So the solution is, number 1, pick 2 equations from the set of 3 and combine such that one equation in 2 variables is obtained. So basically get rid of one of the variables. Again, we see a negative z here and a positive z here. So clearly we can quickly put 1 and 2 together to get rid of the z variable. So equations 1 and 2 are used. These two cancel each other. X and x is 2x, y and 2y is 3y, 6 and 2 is 8. So now we call it equation number 4. Must select equation 3 along with one other equation, any, to eliminate the same variable. Use 2 and 3 to eliminate z. All right, again, the reason we have to use number 3 because it hasn't been used. Okay. Now, so this has to be used. And again, since this is a plus 3z, number 2 makes more sense. It's easier to use this one. And so what we do, if we multiply this one by 3, we can get rid of the z. We have 3x plus 6y minus 3z equals 6 here. So these two cancel each other. These two add up to 4x plus 5y equals 14. We give it a number 5. So numbers 4 and 5 have only 2 variables. So solve the 2 by 2 system of equations using 4 and 5. As soon as we see 4x and 2x, we can see if we multiply this by -2, they cancel each other. So we're going to multiply this one by -2. The result for this one, this doesn't change. This becomes -4x, -6y, -16, and the second one stays unchanged. So they cancel each other. They add up to -y. They add up to -2, and clearly y is +2. So we got the y. We go back to either 4 or 5 because they have only 2 variables. Substitute into either equation 4 or 5. And x becomes 1. Let me quickly show you. So for example, if we go with this one, we get 2x plus 3 times y, 3 times 2 is 8. 2x equals 2, and x becomes 1. The easiest one would be x plus y plus z equals 6, where x is 1, y is a 2. That makes it 3. Subtracted from 6, z becomes 3, and the answer has the following solution set 1, 2, 3. And remember, we use number 1. We have to check with numbers 2 and 3 as well. Just as an example with number 2, x is 1, 2 times 2, 4 and 1 is 5, minus 3 is 2. You can check the third one also. You must check with all 3. I can't emphasize this enough. We're going to get another example. We want to solve this case, x minus 3y plus z equals 1, 2x minus y minus 2z is 2, and x plus 2y minus 3z equals -1. And we're going to go through the same process. We find the easy way out. We get rid of one of the variables and we take it from there. So let's eliminate x from equations 1 and 2. So to do so, notice since this one has x and this one 2x, and we decided to get rid of the x, and you don't have to get rid of the x, you can get rid of the y or z, and any of them is just as easy. If we do that, that means we have to multiply this one by -2. So equation 1 if we multiply it by -2, what do we get? Minus 2x plus 6y minus 2z minus 2, and just write equation number 2. We're going to combine them, and the result we're going to call them equation number 4. These two cancel each other. These two, 5y minus 4z equals 0. So equation number 4 has two variables, 5y minus 4z equals 0. Now, we haven't used equation number 3. We're going to use equation number 3 to eliminate the same variable, namely x. But whether we use 1 or 2, it's up to us, makes no difference. So we can use this one just the way it is, and we can multiply this one by negative or vice versa. Makes no difference, class. You have to multiply one of these two, either 1 or 3, by -1. So if you keep this one intact, this becomes minus x minus 2y plus 3z equals +1. So one more time. In essence, you have equation number 1 here, and you have -1 times equation number 3 here. These two will cancel each other, and it gives us -5y plus 4z equals 2. Now, we're going to put equations 4 and 5 next to each other and solve the system of equations now that has two equations and two variables. You notice these two cancel each other, these two cancel each other, these two add up to 2. Therefore, we end up with 0 equals 2, which is a false statement. And therefore, this is an inconsistent system with no solutions. This is an inconsistent system with no solutions because 0 equals 2 is a false statement. So the fact that we multiplied this one by -1, it gave us a faster result. If we had done it the other way, it would be positive, negative, positive, and we had to multiply it by negative. So this made it a tad faster. Example number 6. Jay borrows $25,000 to pay for a remodeling. He borrows some of the money at a bank that charges 8% interest. At the second bank, he borrows $2,000 more than one-half the amount borrowed from the first bank. The interest rate at the second bank is 10%. The balance of the $25,000 is borrowed from the third bank, where 9% interest is to be paid. The total annual interest Jay pays for the three loans is $2,220. how much does he borrow at each rate? So we have different banks, different rates, different amounts. We have different interests. So let's fill up the following table. Bank number 1, 8%. Bank number 2, 10%. Bank number 3, 9%. That's the rate of interest. So the question is, how much did we borrow from each one? We don't know. But we do know that we borrow a total of 25,000. So this is the total, everybody. So how much? Let's say X, Y, Z. X from the first one at 8%. Y from the second one at 10%. Z from the third one at 9%. And we have $25,000 here, the total amount that has been borrowed. Since we're going to pay 8% interest, the interest for the first one would be 0.08 times X. For this one would be 0.1 times Y. For this one would be 0.9 times Z. And how much is the total amount of interest? So 22 goes here. Wow. If we want to go with this equation first, X plus Y plus Z is 25,000. The second equation comes from the sentence in red or purple. He borrows $2,000 more than 1/2 the amount borrowed from the first one. So the first one was X. The second one is Y. Y equals 2,000 more, 2,000 plus 1/2 the amount borrowed from the first bank. So half of X plus 2,000 or 2,000 plus half of X. And as I mentioned, the amount of interest is 0.08X, 0.1Y, 0.09Z, and 22 is the total. This is the third equation. These three add up. So these are the three equations we have. Three equations. So to solve this system of equations, the first one is very straightforward. Let's get rid of the fractions. If you multiply by 2, you get 2y equals x plus 4,000. And you put them in standard form. You put the x to the left, becomes minus x plus 2y equals 4,000. This really is a good practice, everybody. So we put it in standard form where x and y are on the same side. That's what I mean by that. All right, now we're going to put the three equations next to each other. The first one is fine. The second one, we're going to change it to this one, minus x plus 2y equals 4,000. You can deal with this just the way it is, but since it has two decimals, let's multiply both sides by 100. So this one, we are going to multiply by 100 to get rid of all the decimals. This one becomes 8x plus 10y plus 9z, and you just add two zeros, two more zeros, so that is 222,000. So these are the three equations, everybody. These are the three equations, and I'm calling them 1, 2, 3. Notice equation number 2 has two variables in the first place. We don't have to worry about that. So we're going to use the first and the third one to get rid of the same variable. Which variable? The one that number 2 does not have. So use equation 1 and 3 to eliminate z. Again, why z? Because number 2 doesn't have it. So if we keep this intact, and if we multiply this one by what number? You want to get rid of the z. This is plus 9z. You want to make this negative 9z. Multiply this one by negative 9. Multiplied by negative 9. Minus 9x minus 9y minus z. And you multiply this one by negative 9. You get negative 225,000. And number 3 remains unchanged. So what happens is these two cancel. And so minus x plus y minus 3,000. Now, equation 2 has two variables, x and y. This new equation, we're going to call it number 4, has two variables. So 2 and 4 go next to each other, and we're going to use the system of equations in two variables to solve. And we're going to eliminate one of the variables because both of them are identical. That would be easy to get rid of x. So you're going to multiply one of these by negative 1. It doesn't matter which one. For example, this one. So it becomes positive x minus 2y minus 4,000. This guy is not changing. So these two cancel each other. We get minus y equals minus 7,000. That means y is 7,000. So you can use one of these equations, 2 and 4. But we're going to use 2 because in essence is in the original set. So if you use number 2 minus x plus 2y equals 4,000, that means minus x plus 2 times 7,000 is 4,000, and this is 14,000. And if you move it to the other side, becomes minus 14,000. The sum is negative 10,000. I'm going to call it negative 10K. So if minus X is negative 10K, X is positive 10K. So $10,000. So we have a Y, we have X. We're going to go to one of the original three equations. Obviously, X plus Y plus Z equals 25,000 is the easiest one. 10 and 17, 17,000 subtracted from 25,000. And Z becomes 8,000. And you're going to say J borrows $10,000 at 8%, $7,000 at 10%, 8,000 at 9%. And you really have to check. Basically, when you check with the third one, it's fine. Although even the second one we did change, but it's really was a minor change. If you check with number 3 and it works, and you must, I'm going to leave it for you. That shows that you've come up with the correct answer. At a movie theater, Kyle buys 1 popcorn, 2 drinks, and 2 candy bars, all for $12. Robert buys 2 popcorns, 3 drinks, and 1 candy bar for $17. Lee buys 1 popcorn, 1 drink, and 3 candy bars for $11. Find the individual cost of 1 popcorn, 1 drink, and 1 candy. So first, I'm going to use the initials. I let P be the cost of popcorn, D the cost of a drink, C the cost of a candy. You can go with X, Y, Z, or anything else you want. When you go with the initials in cases like this, I think it makes it a tad easier. So let's make up a table. We know that Kyle paid $12, Robert paid $17, Lee paid $11. For Kyle, we had 1 popcorn, 2 drinks, 2 candy bars. For Robert, 2 popcorns, 3 drinks, 1 candy bar, right? And Lee buys 1 popcorn, 1 drink, and 3 candy bars. Now let's make up the equations. Each one gives us 1 equation. If you look at Kyle, 1, remember, P represents the cost of popcorn. So 1 times P, 2 times D, 2 times C, and that becomes 12. For Robert, 2 times P, 3 times D, 1 times C gives us 17. And finally, for Lee, 1 times P, 1 plus 1 times D plus 3 times C gives us 11. So these are the 3 equations. You solve them by any method. You decide what to get rid of and do the math. Since we have a P and P, we can get rid of the P from the first and the third one by keeping the 1 intact and multiplying the 3 by -1. As long as you multiply one of them by -1, it will do the job. These two cancel each other. We get D minus C equals 1. And we give it a number 4. Remember, originally 1, 2, 3. This is number 4. We have only 2 variables, D and C. Now, numbers 1 and 3 were used. The number that was not used is number 2. So number 2 must be used, which is 2P plus 3D plus C equals 17. And you can use it either with 1 or 3, makes no difference. But whether you use it with 1 or 3, you have to multiply 1 or 3 by -2 because this is positive 2p. So when we do that, this becomes -2p, this becomes -4d, this becomes -4c, and this becomes -24. And now these two cancel each other. These two add up to -d. These two add up to -3c. These two add up to -7. And we call it number 5. Number 4, d minus c equals 1, and number 5 minus d minus 3c equals -7. We put them next to each other. These two cancel each other. These two add up to -4c. These two add up to -6. Divide by -4, and c becomes 1.5. If you divide both sides by -4, you see that. So c is 1.5. You are going to use either equation 4 or equation 5 to get to d. So equation 4, d minus c, d minus c or minus 1.5 equals 1. And clearly minus 1.5 adds to 1, becomes positive 1.5 on the right side. D is 2.5. And you can use any of the original equations. For example, the third one, P plus D, that means P plus 2.5 plus 3 times 1.5 equals 11. This is 4.5 and 2.57. Subtract 7, P becomes 4. So P is $4. D is $2.5. And C is $1.5. Those are the cost of candy, drink, popcorn.